Hi guys, welcome back to the Backend Masterclass. So far we have implemented several features of our Simple Bank system, such as create, update, retrieve, or transfer money between bank accounts. However, there's one very important feature that's still missing: user authentication and authorization. Our banking system could not be completed until this feature is implemented. So today we're going to take the first step to implement it, which is adding a new users table to the database and connect it with the existing account table via some DB constraint. Alright, so this is the current schema of our Simple Bank database. At the moment, the account table has an owner field to tell us whom this account belongs to. So we can use this field as a foreign key to link to the new users table that we are going to create. Let's define table users with an alias u. The first field of this table is a username of type varchar. Every user should have a unique username, so this field can serve as a primary key of this table. Next, we have the hash password field. If we do, which is a very critical security issue, we will learn more about how to store and verify password in another lecture. For now, let's just focus on adding this new users table. Okay, the next field will store the full name of the user, so it is also a varchar type. And forget varchar to use created of now, and it has a default value of now. So Postgres will automatically fill in the current timestamp when the new user record is inserted. Moreover, for security reasons, it's often a good idea to ask users to change their password frequently, like once every month, for instance. So we will need a field password change at to know when was the last time user changed their password. Its type should be timestamp with time zone and should also be not now. As we are using Golang, I'm gonna use a zero value timestamp of Go here. So it should be year 1, month 1, date 1 at 0 hour, 0 minute, 0 second. And the time zone is UTC plus 0. Or we can use the letter Z here, which means 0 time zone. Okay, so that's the definition of the new users table. Now keep in mind that we want to allow one user to have multiple accounts with different currency. So what I'm going to do is to link the owner field of the account table to the username field of just we can see that there's a new link between the username field of the users table and the owner field of the account table. And the number 1 and character star at the end of this link tell us that this is a one-to-many relationship, which basically means we allow one user to have multiple accounts, but those accounts should have different currency. For example, you can have one USD account and one Euro account, but clearly should not have two different USD accounts. One way to set this constraint at database level is to add a composite unique index to the account. Then let's export it to PostgreSQL. I'm going to open this simplebank.sql file. Here we can see the code to create users table. Then the alter table command to add foreign key constraint to the owner field. One way to do that, because requirements change all the time, and it might come after the first version of our system is deployed to the production. And once we have the data in the production DB, we cannot reset it to rerun the old migration. So the right way to apply new schema change is to create a new migration. If you don't create a new issue, you can in Visual Studio for us and paste it for a query. This will be good enough for our new migration up script. Post one text like the account of. Inside the pair constraint, see first setup to apply this because the foreign in the user condition to read down this does make my post to say what change at field has a correct default value, and similar for check the account table. Last migration down version. Hi guys, welcome back. In the last lecture, we've added a new. Hello everyone, welcome back to the password. The password will be key random sort to be used in those iterations, which will help protect against the rainbow table attack. And because of this random sort, the algorithm will give you a completely different output hash value, even if the same input password is provided. The cost and sort will also be added to the hash to produce a final hash string, which looks something like this. In this hash string, there are 4 components. The first part is the hash algorithm identifier. This 2a is the identifier of the bcrypt algorithm. The third part is a sort of length 16 bytes or 128 bits. It is encoded using base64 format, which will generate of the user's password. But when users log in, how can we verify that the password that they entered is correct or not? Well, first we have to find the hash password stored in the database by username. Then we use the cost and sort of that hash password as the argument to hash the password users just entered with bcrypt. The output of this will be another hash value. Then all we have to do is to compare these two hash values. If they are the same, then the password is correct. Alright, now let's see how to implement these logics in Golang. In the previous lecture, we have generated the code to create a new user in the database. And hash password is one of the input parameters of this create user function. Also, in this create random user function of the unit test, we are using a simple secret string for the hash password field, which doesn't reflect the real correct values this field should hold. So today we're going to update it to use a real hash string. First, let's create a new file, password.go, inside the util package. In this file, I'm going to define a new function, hash password. It will take a password string as input, and will return a string or an error. This function will compute the bcrypt hash string of the input password. In this function, we call bcrypt.generateFromPassword. It requires 2 input parameters, the password of type byteslice and the cost. So we have to convert the input password string to byteslice. For the cost, I will use the bcrypt.defaultCost value, which is 10. The output of this function will be the hash password and an error. If the error is not nil, then we just return an empty hash string and wrap the error with a message saying failed to hash password. Otherwise, we convert the hash password byteslice to string and return it with a nil error. Next, we will write another function to check if a password is correct or not. This function will take 2 input arguments, a password to check and the hash password to compare. It will return an error as output. Basically, this check password function will check if the input password is correct when comparing to the provided hash password or not. And the standard bcrypt package has already implemented this feature. All we have to do is to call bcrypt.compareHash and password function and pass in the hash password and naked password after converting them from string to byte slices. And that's it, we're done. Now let's write some unit tests to make sure these 2 functions work as expected. I'm going to create a new file, passwordtest.go, inside the util package. Then let's define function testPassword with a testing.t object as input. First, I will generate a new password as a random string of 6 characters. Then we get the hash password by calling the hash password function with the generated password. We require no errors to be returned. And the hash password string should be not empty. Next, we call checkPassword function with the password and the hash password parameters. As this is the same password we used to create the hash password, this function should return no errors, which means correct password. Let's also test the case where an incorrect password is provided. I will generate a new random wrong password string and call checkPassword again with this wrong password argument. This time, we expect an error to be returned, since the provided password is incorrect. To be exact, we will use a require.equal error function to compare the output error. it must be equal to the bcrypt.error mismatch hash and password error. Okay, the test is now completed. Let's run it. It passed. Awesome. So the hash password function is working properly. Let's go back to the user test.go file and use it in the create random user function. Here I'm going to create a new hash password value by calling util.hashPassword function with a random string of 6 characters. Require no errors. Then change this secret constant to hash password instead. Alright, let's run the whole DB package test. All passed. Now if we open the database in Table Plus and check the users table, we can see that the hash password column is now containing the correct bcrypt hash string. It looks just like the example I showed you in the beginning of this video. One thing we want to make sure is, if the same password is hashed twice, 2 different hash values should be produced. So let's go back to the test password function. I'm going to change this variable's name to hash password 1. Then let's duplicate this hash password code block and change this variable's name to hash password 2. What we expect to see is the value of this hash password 2 should be different from the value of hash password 1. So here I used require.not equal to check this condition. Okay, let's rerun the test. It passed. Excellent. But to really understand why it passed, we have to open the implementation of this bcrypt.generateFromPassword function. As you can see here, in this new from password function, a random sort value is generated, and it is used in the bcrypt function to generate the hash. So now you know, because of this random sort, the generated hash value will be different every time. Next step, I'm going to use a hash function that we've written to implement the create user API for the API that we've implemented before. So I'm just going to copy it from the account.go file. Then let's change this struct to create user request. The first parameter is username. It is a required field. And let's say we don't allow it to contain any kind of special characters. So here I'm going to use the alphanum tag, which is already provided by the validator package. It basically means that this field should contain ASCII alphanumeric characters only. The second field is password. It is also required. And normally we don't want the password to be too short because it will be very easy to hack. So here let's use the min tag to say that the length of the password should be at least 6 characters. Okay, the third field is full name of the user. There's no specific requirements for this field except that it should be required. Then the last field is email, which is very important because it will be the main communication channel between the users and our system. We can use the email tag provided by the validator package to make sure that the value of this field is a correct email address. There are many other useful built-in tags that were already implemented by the validator package. You can check them out in its documentation or GitHub page. Now let's go back to the code to complete this create user function. Here we use the context.shootByJSON function to bind the input parameters from the context into the request object. If any of the parameters are invalid, we just return bad request status to the client. Otherwise, we will use them to build the db.createUserParams object. There are 4 fields that needs to be set: username, hash password, full name, and email. So first I'm going to compute the hash password by calling util.hashPassword function and pass in the input request.password value. If this function returns a not nil error, then we just return a status internal server error to the client. Else, we will build the createUserParams object, where username is request.username, hash password is the computed hash password, full name is request.fullname, and email is request.email. Then we call server.store.createUser with this input argument. It will return the created user object or an error. Just like in the create account API, if the error is not nil, then there are some possible scenarios. Keep in mind that in the users table, we have two unique constraints. One is for the primary key username, and the other is for the email column. We don't have a foreign key in this table, so here we can remove the foreign key violation codename from this case, and leave the unique violation codename here to return status forbidden in case a user with the same username or email already exists. Finally, if no errors occur, we just return status OK with the created user to the client. Okay, so now the create user API handler is completed. The last step we must do is to register a root for it in the server.go file. Here in this new server function, I'm going to add a new root with method post. Its path should be /users, and its handler function is server.createUser. And that's it, we're done. Let's open the terminal and run make server to start the server. I'm going to use Postman to test the new API. Let's select method post. Fill in the URL http:/localhost port 8080/users. For the request body, let's choose raw and select